the prerequisite for modern life. It enables logistics, healthcare, communications, and yes, cybersecurity. Today we're talking about how fragile that foundation really is. From frequent attacks on substations with no clear motive, to regional blackouts across the Iberian Peninsula, and purposeful destruction of the Nord Stream pipelines, the lesson is the same. Energy systems fail in more ways than people planned for. My guest today is CAT Chief Instructor Brian Harris. We're going to discuss why energy infrastructure is not a niche concern, but a frontline security issue. So, Brian, before we get into specific incidents, I'm hoping that you can kind of set the frame for us. Why is power the single most foundational dependency that we have?
Right. So basically everything is downstream of energy, right? Everything is downstream of electricity. So, you could say water, but water is reliant on pumps, which are reliant on electricity. You have cybersecurity, which is reliant on the servers and the computers and everything's actually having power. Everything within your civilization is downstream of electricity. So when the electricity goes out, everything else is basically moot, right? Like what's the point in guarding your server from a cyber hacker if there's no electricity and the server's offline? So I mean, it's one of these things that without power, there's really nothing in regards to cybersecurity. But it goes far beyond that. Your hospitals, your lights, your water, your public transit. If you've got rail systems and other things, everything is going to be shut off. And we saw that with the certain instances like the Iberian Peninsula, blackout, Spain and Portugal and all that. But yeah, you need to take care of your electricity. Otherwise, everything else is going to basically fail.
Why do you think this matters for cybersecurity professionals? Like, why should energy infrastructure be treated as mission critical, even if it's not, quote, their asset?
Right. So, okay, take organization. So anybody who's listening to this, if you've ever been a consultant before and you've asked the question to your client, what is it that keeps you up at night? What's the thing that would catastrophically destroy your company? A lot of clients, a lot of businesses will say some derivative of downtime. Right? If we can't ship our merchandise, if our website goes offline, if we can't push out our product or our message for such a period of time, maybe it's a day, maybe it's a week, maybe it's a month, they'll say, look, the bills will stack up. We're operating on a really slim margin here. So you realize that if your client, whether that's think of a bank, right? How long could a bank be offline completely before all hell breaks loose? No ATM machines are working. You can't draw money. You can't take out, you can't use your credit cards. So when you're dealing with this, if the electricity goes out, ask yourself the question of how would that affect my business, and do that based on depending on how, specific you want to get, you might look at it on a daily basis. You might look at it on an hourly basis. I've had clients before who have literally said, look, we've done a risk analysis and we've said that if our website were to go down for even 2 weeks, our entire business would be shut down. Because that's the margin that's the margin that they're operating on, right? So you have to, you take these things into consideration. And at the same time, what if you're a broadcaster? What if you're news or anything else? So even big players, BBC, CNN, etc. Well, what would happen if they couldn't broadcast their stuff for 2 weeks, right? See, we make the mistake of looking at power outages and measuring them in hours, and we tend to look at them as more inconveniences. But like the Iberian Peninsula, I think it was out of power for like a day or something. And I think about 10 people died as a direct result of this. And, you start asking the question of okay, yeah, if your entire country tomorrow was blacked out, there was literally no electricity. Well, your hospitals might have power for a day, maybe 2, and then the emergency generators are out of power, right? Like you don't have water, you don't have like all of these things. But then when you think about cybersecurity spans everything, right? Everything from self-driving cars to websites to critical infrastructure to hospitals to server rooms to data centers. Cybersecurity is interwoven into everything. But if the power goes out, well, then there's nothing you can do. It's, but also realize that if the power goes out, you probably have no physical security either. Because take something like a mag-lock door, for instance. Mag-lock doors are basically just big electromagnets. Well, not big electromagnets, but they're basically just electromagnets, right? They need electricity to keep the doors closed. And most of these systems basically fail open, meaning that if the electricity goes off, all the doors open. Okay, well, and you understand why, right? We don't, in the
Yeah.
case of a fire, you don't want to trap people inside the building. Okay, but if everything fails open and all the power's out, and what's going to inevitably happen when you have blackouts? Riots, looting, these types of things.
Sure.
Okay, well, the police are going to be very busy because there's going to be, stuff like this happening everywhere. Mm-hmm. And who's going to be protecting your data center? Who's going to be protecting your facility? If your client tells you the server room, the data center, these types of things are absolutely critical to us. Well, realize that if all the power goes out, your building may have no security whatsoever. The cops are going to be preoccupied doing other stuff. And so, then it goes back to something I've talked about before, but what is the average response time for police in your area? It's like, okay, well now astronomically delay it. Because
Sure.
that average response time is assuming that everything's working and functioning properly.
Now, I think it's kind of like physical security in general. People often are unaware how frequently these events occur. So perhaps you could kind of tell me a little bit about how common these attacks are.
Yeah, so according to the Department of Energy, there's an attack on the grid in some way, whether it's a cyber attack, somebody trying to blow up a transformer, somebody trying to shoot a substation, something that happens between 1 and 300 times a year, roughly. So basically
100 to 300,
yes.
not one.
Sorry, sorry. 100 to 300
Sure.
per year. So basically you can look at this and say that without loss of generality, between every day and every third day, so every 24 to 72 hours, somebody's trying to take down, disrupt the power grid in some way, shape, or form.
In the U.S. alone.
In the United States alone. And that's either through the internet or through physical means or something else. And oftentimes they don't succeed, luckily. But there are a lot of times where you are going to succeed, and you're going to take down power for, usually thousands of people. Because it's power being distributed to an area. And the problem is, well, let me say it this way. Fortunately, most attackers are idiots. Most attackers are not state entities. Most attackers are not even remotely clever. They've not even done their due diligence of understanding how things work. And thank God they don't. Because if they did, they might be able to create like a cascade failure, which is a whole different problem. But yes, you do have people attacking the grid just in the United States on almost a daily basis.
Now, you had a recent article about just the vulnerability of substations in particular. So I want to start off by talking about what exactly is a substation doing within the grid infrastructure and why is it such a critical juncture?
Right. Okay. So now, again, without loss of generality here, your power distribution usually has three main components to it. You have your power distribution. That's your wind farm, your solar farm, your gas, coal, whatever. The thing that's producing the energy. Then you have the substation, which is, you can think of the substation as a load changing device.
Okay.
So energy drops off with distance, right? You're never going to have a power station in Moscow trying to power the lights in New York because the power would drop off so much on that line that by the time the electricity got to New York, there'd be nothing coming out of it. So what you have to basically have kind of like relays. You have to, as the energy kind of gets to a certain point, you have to either up or down regulate the voltage so it can either go farther or less, depending on distance. The power in the power station is usually produced at ridiculous voltages, thousands of volts, right? Well, we can't have thousands of volts coming into our homes because you'd have electricity shooting out of your walls.
Sure.
Right? That'd be bad. So you usually have transformers and substations that down-regulate the voltage when it gets close. So the three main parts are you have the thing that's producing the power station of whatever it is. Then you have the substation, which is either up or down regulating the voltage, depending on how far it needs to go. And then you have the distribution point, where it's usually a house, a city, a location, an entity, the thing that's taking the power, right? Now, when you start thinking about, okay, if you were a bad guy, how would you disrupt power? And it's like, well, if you did it at the distribution point, like a city, you'd have to go house by house, street by street, cutting the power lines. And very quickly you'd get caught, right? Because all the power lines are distributed to every single house and every single building. And if your idea was I'm going to black out the city, and you're saying I'm going to do that at this distribution point, well then I'm going to have to go again house to house, block to block with bolt cutters or something and try to cut that stuff and hope to God that you don't get shocked. If you try to do it at the power plant has a lot of redundancies built into it. It's built well.
It's probably also a lot more secure.
It's infinitely more secure. And then you have the substation. And I encourage everybody to Google a picture of a substation. They are usually just basically a series of transformers with cable lines running to them, usually guarded by a chain link fence in the middle of a field and nothing else.
Sure. And
you realize that is the bottleneck, right? All the power is coming through them.
And you'd say it's a bottleneck versus a node because one can't really replace the other.
No, all the electricity comes through that point, right? So it's one of these things that, like, the distribution point, like a house, would be a node, but the substation itself it is definitively the bottleneck of electricity. And it's also the most vulnerable because unlike the power station, which usually has guards and access control systems and a buttload of cameras, and it's on like emergency alert for police if the alarms go off at the power station, like people are hauling butt to get there. But the substation is usually in the middle of nowhere or on the edge of a city, and it's guarded by nothing. But that's where all the electricity is funneling through.
So from a defender's perspective, what is so striking about how exposed these substations are?
Well, it's exactly what I was saying earlier, is that, you have the power station, which is basically like a little fortress, and it's well guarded. But then you have the substation, which produces all the electricity. So, the Mexican cartels and certain people down at the southern border of the United States, they kind of demonstrate this point very well in a totally different way. When you think about like a water treatment facility, same idea, right? Lots of security. Usually the police are kind of on standby. Okay, if something goes wrong there, it's that's serious, right? If somebody breaks into a water treatment facility, that's a serious problem. But before the water gets to all the houses, it has to be pumped there. And then you start looking at regulations and you start asking questions like, how deep does the water pipeline have to be? And it's usually only a few feet of dirt. And if you know where those pipelines are, what happens down in the southern border of the United States and other places is that you do what's called hot tapping, where you find where those water pipes are in the middle of nowhere, you get a shovel, you dig up one of those pipes, and you hot tap into it, and you start stealing water.
Sure.
And on the southern Mexican border, if I remember correctly, it's something like 3 million gallons of water a day is stolen.
Wow.
And that's a lot of water, right? Like 3 million gallons of potable water, I believe it's daily, is stolen through hot tapping. And basically just theft into an active water pipe. And you can kind of see that, okay, well, if you had wanted to get water from the water treatment facility, that would be a really big issue. And there's no way that you could do that 3 million gallons a day and get away with it. Mm-hmm. And it'd be tricky to do that at the distribution point of people's houses, right? I don't even think that a house could pump out 3 million gallons of water, before water was shut off or people showed up to your house to ask what the hell. But if you do it at the water pipe in the middle of nowhere that's guarded only by a few feet of dirt, okay, yeah, that's easy.
Well, and it's more than just theft, because I feel like it increases the financial power of the cartels, because they're basically getting free water for growing anything that they might want.
That's a whole other thing. They'll sell it. They'll turn around and sell it.
Well, and also I think it's a water security risk, because it's like, okay, it's unsanitary. Do they know how to do this safely, properly? Like,
well, that gets into a different topic, which we're not going to discuss. But I will leave that topic with this thought. It's a fairly simple structural engineer problem, or mechanical engineer problem, where if you have a pressurized pipe, how do you connect another pressurized pipe to it without losing pressure? And I will leave that topic there, but I will say, yes, there is a big, big, big security risk of being able to connect one pressurized pipe to another pressurized pipe in this particular instance. But this is the kind of thing that, again, if you wanted to access the water of people, like going to the water treatment facility is hard, and you have to deal with security and cameras and alarms and
Yeah, it's getting it from A to B. Those are the
exactly
potential weak points.
Yes, that's what you're looking for. You're looking for the weak points. You're looking for that soft underbelly of like, oh, well, if I dig up a few feet of dirt here, there's no security.
So let's talk about, this has happened, an attack has happened.
Mm-hmm.
How long does it realistically take to replace a large substation today?
Right. See, this is the problem, is that if a substation... So first off, most countries do not have emergency substations on standby. We have what's called emergency mobile substations, and that's a different thing. An emergency mobile substation is basically a substation on the back of a flatbed truck. In the event that a substation goes offline, you bring an emergency mobile substation to take over the load, and then power's only out for a little while until that substation can be brought in and take over everything, and okay, you're good. However, to actually replace the substation, because you can't just leave a mobile substation there indefinitely, right? At some point, you have to actually replace the thing. The problem is that most countries do not have warehouses full of substations just lying around. They have to build them. And depending on the voltage that the substation is going to be handling, that can take usually years, right? You're looking at anywhere from about 36 to up to like 60 to 70 months, right? So it's a lot of time. It's a long downtime. And so the issue here is kind of the cascading problem of if your country has, let's say, one mobile substation. So if one substation goes offline for any reason, terrorism, accidents, fires, whatever. Mm-hmm. In the event that happens, you can bring in one emergency mobile substation and you're good to go. But now, that's an n equals 1 problem. If n equals 2 and 2 substations go offline, somebody's going without for 36 months, right? And see, that's the problem.
And how long does it take to build a mobile substation?
It's same because it's literally just a substation. It's just you have it on the back of a truck. But see, that's the problem. The problem is this downtime. Is just that we look at this in the sense of like, okay, well, we have this just-in-time kind of resilience. Like, we have just enough to get by, but we don't really have anything in reserve here.
And the interesting aspect of that is that might work when it's an accident because accidents are fairly rare. So what are the chances that 3 different locations will have an accident at the same time? But when it's like a coordinated attack, which we know is becoming increasingly more rare. I know in your blog post I was shocked. Or more common. In your blog post I was shocked to see that it went from like 100 a year to it doubled in 2 years' time in the U.S. alone.
Correct.
Like, if it's coordinated, then all of a sudden that, n equals 3 is a lot more likely than, we're only factoring for accidents.
Correct. And see, that's kind of that's where the mindset needs to shift. But the problem with this is that in most instances, these emergency mobile substations and things like this are privately owned.
Really?
Yes. So you get companies that produce or power or like basically your power company, right? It's usually your power company that is in charge of this. Your military will probably have a couple. And we're not going to be told how many the military have because that would be a national security secret, right?
Sure.
If your adversary knew, they have 5.
Yeah, but let's hope it's a lot.
you hope that it's a lot, but the chances are it's not as many as you want it to be. And see, that's the problem is that but the bigger problem here is in lieu of the military being brought in, how do you convince a private entity to just buy up a bunch of extra mobile substations? They're exceedingly expensive. They're also exceedingly difficult to just stick in a warehouse. That's why nobody does it. Nobody builds substations and puts them in warehouses because they'll rust and they'll get old. And so you don't typically do this because it's not cost effective. Because the instance where you actually need to replace them is not, like full on replace the entire thing. That's not typically very common. So how do you, but in the event that somebody actually successfully takes one down, how do you get one when you need it, right? See, this is the problem. This is the big problem. This is that you need these things in reserve for resilience, but then you have to convince private companies to invest a ton of money in something they probably will never need to use.
Sure.
That's the problem.
Sure. So speaking of like military assets, I'd like to talk a little bit about the incident that happened at Fort Bragg.
Sure.
So maybe you could give us a little bit of background information for people who may not have read that blog post of yours.
Right. So, okay. So for those who don't know, Fort Bragg is the largest military installation in North America. It's home of Special Operations Command, JSOC, and the Airborne, and a whole bunch of really important stuff, right? So the problem here is that Fort Bragg gets its power from the civilian grid. So what some gentleman, who, as far as I know, was never caught, was able
I wouldn't call him a gentleman.
Yeah, well, was able to figure out was that if he took one substation offline that was powering Fort Bragg would fundamentally go offline. Mm-hmm. So, it's a fascinating question, right? Because if you think about ahead of time, how would I take out power to the largest military installation in North America?
You would hope it'd be a complex
right,
answer.
You would expect some Ocean's 11, Jason Bourne level types of stuff. But in this particular instance, all this guy did was he brought a large caliber rifle, 30-06, 308, something, stood off at a distance and shot the substation. Mm. So the reason why that's effective is that what a transformer really is a transformer is basically just a big iron donut that's sitting in a vat of oil. So it's a big iron donut with different amounts of coil of wire on two ends of it, and it sits in a pool of oil. And the oil and the little fans on the side of this thing keep it cool, right? Think of it like a big-ass light bulb, mm-hmm. right? But the light bulb gets way, way, way hotter than a normal light bulb. So you have to submerge it in oil and have heating fans on the side of it to keep it cool at all times. By shooting this stupid thing, the oil leaked out. And substations are not like a light bulb or like a light switch. You can't just flip them off, right? There's a series of steps you have to go through in order to turn this off. The problem is that once you start damaging substations and transformers in this way, now you're in a race. Now you're in catastrophic event, oil pressure dropping, temperature drastically rising. Can the engineer notice and shut it off faster than the thing destroys itself? That's the question. Now,
can they?
That's the question, right? So how many holes did you put in it? Because that's going to dictate how fast this changes. Mm. If you put a whole bunch of holes in that thing and the oil leaks out really, really, really fast, it could heat up so fast. Like, let me say it this way. If your substation, or whichever substation we're talking about, let's say that there's a downtime of, let's say there's a 10-minute delay from the time the first alarm goes off until the power is off. There's a 10-minute delay. Mm-hmm. Okay. Well, you had better hope that thing does not get critically damaged with under 10 minutes.
Yeah.
Right, so that's really the problem. And then what a lot of people today say, they'll say, well, our substation has this and that, automated protocol, and it'll fix this and it'll fix that. And it's like, have you tested it? Do you know if it'll work? Or is it just like a vendor promise?
Sure.
Right?
And we know what those are worth.
Right, exactly. And so it's one of these things where, and not all substations, have these abilities. So in this particular instance, somebody stood off a few hundred meters, shot the thing, oil leaks out, and the substation goes offline. Emergency mobile substation has had to be brought in, and power is restored.
So it did leak enough to cause damage.
Well, yes. I mean, think of it this way. Like, regardless, you have to take the thing offline because you have to repair it.
Yeah.
Right? At some point, even if it's not critically damaged, even if it's just, we need to weld the tank and refill it with oil, okay, even if that's all it is, you can't have the voltage going through it while you're trying to fix it. So, the whole point of that is that now one of your emergency mobile substations is on station fixing that thing until it's repaired.
Sure.
So now you have an N=1 problem, but the instance here is very simple. Guy with gun shoots substation goes offline. While substation is offline, largest military installation in North America fundamentally does not have power. Now they have emergency generators and they have other things that can help them with that, but you can see just how, when you ask the question, take power out to big military installation, you don't typically think guy with gun.
Sure.
Right?
Single guy with gun.
Yeah,
Could be a drunk guy with a gun.
You think of something far more complex, far more robust, far more intricate. But this is the problem with kind of an OT environment is people don't realize how fragile it is. People don't understand that substations especially, they are very fragile. Mm-hmm. And the instances here is if it goes offline, now it is a multi-tiered challenge of can you shut the thing off before it fries? Because remember, if it fries, you need a new one.
Yeah.
And that means
36 months.
Exactly, right? A really long downtime. Yeah. But then on top of that, the question is, do you happen to have an emergency mobile substation, and is it free?
Well, and I remember one aspect of the Fort Bragg blog was that they had to expend a lot of resources to ensure off-base personnel still had whatever they needed. And so it's not just about, personnel on base who have access to the generators and things like that. They have to spread resources out just to...
Right. Yeah. So this is, again, yes, that's absolutely true. Because if I remember correctly, the entire county was out of power. And but see, this is the problem, is that you took one guy. Well, keep in mind, as far as I know, he was never caught. And keep in mind,
and we don't even know it's a guy.
Well, sure, but when you look at Google what a substation looks like, and then look for cameras that are on the substation that could pick out a human face at 200 yards, and you're not going to see them, right?
Why don't these have concrete walls?
Right, exactly. But see, that's a great question, right? Why don't you have some kind of like HESCO or some kind of barrier that would stop this exact attack from happening? It's a relatively inexpensive type of thing, but you realize how easy... Okay, so the attack here is guy with gun shoots at it from outside the fence line at a distance where even if they have cameras, you can't pick up a face. Okay, why wouldn't you have some kind of barrier that could actually protect it? And the answer will come back to one thing: money.
Yeah.
It'll come back to, well, we didn't think of it, or it would cost too much.
But it doesn't even necessarily need to be a fence that stops a bullet. It could just be a fence that stops them from seeing the thing that they want to shoot.
Well, that's not really going to be effective.
Oh, because thermal guns and stuff?
Well, you don't need thermal, but you just shoot it. You know it's in there.
Oh, spray and pray?
Yeah, basically that. Right? Well, think of it this way. Think about like offshore substations. Right? So if you think this is bad, of substations that are sitting in a field, imagine offshore substations. Well,
at least you need a boat for those.
Well, you do. You do need a boat for those. But, imagine the complexity of... You can't bring an emergency mobile substation on station there. Imagine the sheer complexity of the exact same kind of attack occurring offshore. And it's like, yeah, okay, so... But see, this is the problem, is that the issue is these things are far more fragile than people think, and thus far, you're really only looking at an N=1 problem. One substation goes down at one time, but if it was to be coordinated, you are in this cascading problem, and it seems like nobody's actually considered this. Nobody's actually even thought of, okay, how do we fix that if that actually occurs?
Well, yeah, and speaking of offshore, the Nord Stream... pipeline destruction,
Yeah, sure.
That's a huge one.
Well, right. So here, yeah, it's, again, you have a massive amount of critical infrastructure resource being pumped out through a pipeline that's accessible. And I will say, in air quotes, ironically, nobody seems to know who blew this thing up. But yes, you blow it up.
I thought they did know. I thought they...
There's a lot of we know, but just for the sake of... Yeah.
Allegedly.
Yeah, allegedly. For the legality of it, just allegedly. But yeah, it's... You have a lot of resources in transit, and that's the soft point. That's the soft point where you can attack it, and again... Nobody seems to be concerned about that. Nobody seems to think it could happen. Everybody just, it'll be fine. Yeah. It'll be fine.
And then we keep seeing instance after instance where events do happen.
Well, you do. You have these instances, again, just in the United States alone, between 1 and 300 times, per year, you have these attacks on the grid. And it's not a rare occurrence. So it is shocking to me that people still treat it as if it is a rare occurrence.
I know I was the one who brought up the Nord Stream pipeline, but do you feel like it is relevant in this conversation because it's another way that energy is transported and transportation is the security weak link? Because in my head, that makes perfect sense, but...
To be fair, it's not really relevant anymore, because it's been blown up. But no, for the topic of discussion, yes, it is once again a question of, if you look at the distribution of gas in this regard, you have the distribution point, the place that's actually manufacturing it. You might have a few refineries. Then you have the pipelines, and then you have the distribution point where they're all going to pick it up, right? And if you asked, what is the bottleneck? It would be that pipeline under the seabed.
Yeah.
It's like that would be the bottleneck. And see, this is the part, I've talked about this in the past where, security has three components to it. So the three components of security are your compliance. Do you have the things you need to be secure? Mm-hmm. Your defense. How are those things actually used? And then your offense, being a reality check for the defense. Mm. And the problem here is that the offense usually gets paid lip service, if anything at all, because it would be trivial for an offensive guy to look at substations and look at these problems and say, this is how I would attack this if I were a bad guy. And so this is what you should probably fix.
Sure.
Right? And so in a lot of instances, like you had brought up the idea of just putting out some kind of concrete barrier to protect from gunfire on substations. Yes, that is a very inexpensive way of solving that problem.
Oh my goodness.
Does it actually fix it? No, because somebody could hop the fence, somebody could hop the barrier, and then shoot the thing. Yes, of course that's possible, but you've stopped the ability of them shooting off distance where they have autonomy.
Sure.
Or anonymity, right? Because you now have to hop a fence. You have to be in a highly dangerous OT environment because if you're inside an active substation, you always have the risk of arcing and literally
so there's
dying.
personal risk to you.
Massive risk to you.
You could put up some barbed wire on the top and cameras on the corners, and all of a sudden...
you force the bad guy to literally get nose to nose with this thing to disable it. And it's like, and at that point, he can't just sit with a rifle, 200 yards away and shoot the thing.
Sure.
Right? But I think the reason why you don't typically see this is that you don't ask offensive security people to take a look at these infrastructure points and say, how would I take these out? How would a bad guy do this?
With all of these instances, though, and the growing occurrence of them, is that changing? Somewhat.
It's changing, but in my opinion, it's not changing fast enough. Like you do see more and more entities, you see more and more organizations in the IT and OT and spaces starting to come to offensive people and ask them questions, but it's not happening fast enough, in my opinion, because again, if you took any smaller country in Europe and you had 10 idiots who all did this type of attack simultaneously, I don't know if they could recover from this, right? That's not a giant, coordinated, massive military intervention. That's 10 morons with, minimal training. And so this is the problem, right? So let's look at the dichotomy of attacking the grid through the internet and attacking the grid physically. If I told somebody, I would like your challenge is to go through the internet, get onto a substation or onto the power grid through the internet and take out power to a whole city, right?
Sure.
How much training would that require?
How much time?
How much time would it require? How much, diligence and 0-day exploits? You're not talking about I couldn't give you a weekend course and be like, okay, go do it. Right? You're talking you're probably talking about a lot of expertise and a lot of coordination and probably some social engineering and all kinds of things. It's a big, heavy lift. But physically, well, again, go back to the Fort Bragg instance. One moron, probably with a couple beers and a gun, right? Okay, well, how much training does that take? Nothing. It literally requires nothing, no training. So this is the difference, right? There's levels of bars of entry for accomplishing the same task. And we put all of this time, effort, and resources to defending the one and seemingly nothing in defending the other, despite the fact that the physical aspect of things is far more vulnerable, in my opinion.
So then, given that, how should defenders think about these assets that are... Because it is hard to guard things when... substations are a little bit easier than, say, like a pipeline, because the pipeline goes the entire way.
Right.
But, it's a lot of resources to protect. So how are they supposed to think about these hard to guard but easy to disrupt assets?
Well, okay, so first off, the defense shouldn't have to ask these questions. That should be the job of the offense. The job of the offense is to do exactly what you just said. We should be the ones looking at all of these and saying, okay, here is what you, the defense, should be prioritizing. Go prioritize it. Well, not every substation is equally vulnerable. Not meaning that, so let me clarify that. All the substations, mostly, are equally vulnerable to the same type of attack. But some substations have built-in, not the substation itself, but some grids have built-in redundancies. Meaning that if this substation goes offline, we can reroute power to another substation so that the area, the city, does not go out of power, right? Doesn't get blackouts and other things. So if you have a grid that is set up with, let's say, 4 redundancies, then if any one of those 4 substations were to go offline, you're okay. You're not okay if all 4 of them go offline.
Sure.
But as long as only 1, 2, or 3 go offline, you're fine. So that example is not as vulnerable as a city that has 1 substation, i.e. Fort Bragg, right? Because if your redundancy is 0, then that's really critical, right? And so one of the aspects of the offensive team would be to figure out which of these is extremely important to protect, right?
Yeah.
So, but I mean, again, you just need to look at this through the lens of a bad guy and then help the blue team or help the defense say, okay, this is where you should, prioritize your defense, right? And I mean, it's not rocket science. It's really just understanding the mind of the bad guy and saying like, okay, look, if I was the bad guy, this is the low-hanging fruit. And this is what we refer to as asymmetric attacks, right? An asymmetric attack is simply, from the bad guy's perspective, you are risking very little, you're using very little effort, and you're accomplishing a lot.
Sure.
Right? It's the low-hanging fruit. That's all you're looking for here. So but again, if you're not going to ever be consulting the offensive teams on stuff like this, then your defensive teams are probably going to be thinking they're doing everything right because the substation hasn't gone offline and power is still generating and everything else until it's not.
Yeah. And I mean, we've talked a little bit about accidents. Because they do happen.
Sure.
But we've spent most of the time talking about malicious attacks.
Right.
But accidents do happen, and they're happening with increasing regularity.
Right.
Just this past summer, the Iberian Peninsula had those, huge blackouts.
Yep.
Can we talk a little bit about that?
Yeah, okay, so this is going to be a topic that might upset a lot of people, but your green energy adds volatility to the grid.
Sure.
So green energy, wind, solar, etc., these are all natively direct current kinds of energy, right?
Okay.
Your grid is all alternating current. So there's a whole lot of issues with the green energy and hooking it up to the grid. You have a grid that is specifically set up to have alternating current, and we could go into the history of that in the physics, but your grid is set up to be alternating current, and you're hooking up a whole bunch of little things that are all direct current. So in order for that to work, you have to put up a whole series of steps in between the green energy and the grid to invert it and everything else and get it to be AC on an AC line. But the Iberian Peninsula instance, at first, the REM, the power company, said, well, we think it was a fire in southern France. And that took out a power line, and that caused a cascading failure. Okay, well, that in and of itself is a huge admittance, right? If the power company is saying a single fire that takes down one power line can take out power to literally all of Portugal, all of Spain, and parts of southern France, that in and of itself is a huge admittance of like, well, yeah, we know that if there's a fire in this one area, all of Spain and all of Portugal and parts of France are going to go without power.
Sure.
So that in and of itself was a huge issue. But then later, what they seem to have come to was they basically said there was a huge voltage spike on the line, and it led to a cascading problem, which, again, if you have a voltage spike, it's probably not coming from your base load. It's probably coming from one of your wind turbines or solar panels or something, and you couldn't turn it off. When you go, anybody who's driving past wind farms, the big turbine things, what you'll often see is a lot of them are off, even on windy days.
Yeah.
And the reason why is one of two things. One, they're broken and they need to be fixed. Or two, they are producing or could produce too much energy, and so you have to turn them off so that they don't spike the grid, right? And so if it suddenly gets very windy very fast and you can't turn those things off fast enough, you can have basically a voltage spike. And if that voltage spike is big enough, you can have something that what happened in the Iberian Peninsula. Now, it has not officially been said that the voltage spike was from a wind turbine or something else, but that's, in my opinion, most likely. So I will just use the legalese allegedly. But the problem here is that the way that substations and the way that all of your OT infrastructure is set up is that it's kind of like a series of breakers in your house. So that the hardware doesn't fry, if there is a spike, they shut off. So to save them from catastrophically breaking, they just shut off. Well, that's basically what happened in the Iberian Peninsula, is that one shut off, and then 2 shut off, and then 3 shut off, and then you had a cascading blackout. Now, the problem with cascading blackouts like this is that you have to do you have to restart all the grid from nothing, and that's a huge mechanical pain in the butt, and it's not something you ever want to do. So, just having a grid on AC current alone is a marvel. In Europe, for instance, the grid is oscillating at 50 hertz. Now, think about the intricacies of this. All of the power grids, all the power supply, everything, all over Europe has to be in perfect sync at 50 hertz within a 1% margin of error. Imagine if you needed to flip on and off light bulbs manually 50 times a second, or let's just say 50 times a minute, and you were trying to coordinate that with one other person by radio, and you had to be within 1% margin of error when you're flipping it on and off. That in and of itself is just a marvel that you can pull that off, right? But that's basically what you're trying to do at scale. So when power goes out like that, especially countrywide or multiple countries wide, getting it all back up and running is a huge gamble. It's a huge,
undertaking.
Well, it's a huge undertaking, but it's very, very stressful because you don't know if you're going to do it right. You don't know if you're going to break something. Because remember, if something breaks, then it's not just, oh, we can flip it on. It's, oh, it broke, so we need to
fix it.
Now we got to fix it, and that might take months or years to fix whatever we broke. So it's a huge stress point. But in this instance, as far as I know, this was basically just an accident. You had a huge voltage spike on the grid. It caused a cascading failure. It blacked out everything for, I think, a few days. About 10 people died because of the blackouts. That's kind of the point, right? Is that one problem causes a cascade event. And again, this wasn't, as far as I know, this wasn't a coordinated malicious attack. But imagine if you added that component to it.
Absolutely.
Right? So
it sounds like this may introduce new vulnerabilities, new opportunities for an attacker to take advantage of.
Possibly. Well, there's some research coming out of Germany a few years back that kind of talked about this, but that's a different topic. But yeah.
All right. Because I did want to ask that question, how does this increased complexity, load changes, weather, create conditions that attackers could exploit without doing much themselves?
Right. It's just like anything else. When you have more and more moving parts of a system, to break the system becomes easier because you have more possible places that you can, disrupt something or break something. And so in Europe, for instance, there's very kind of like this incestuous power supply where all the countries tend to get power from each other. Well, that's great because it adds some redundancy, but it also adds the vulnerability that if one country goes out, that could screw other countries going out, right? So similarly, again, like you have one voltage spike in one part of one area, and it causes all of Portugal, all of Spain, and parts of France to go offline for a few days, right? So because they're all interconnected this way, you do have redundancy, but you also have vulnerabilities.
Sure. So, on one hand, we've got increasingly complex and in many ways fragile systems. We've got an increasing number of attacks, and we also have an increasing demand on our power supply, for example, with not just like population growth and generally people using more energy, but also like AI, data center demand, all of those sorts of things. So how does that sort of amplify the risk?
Right. So the AI thing is fascinating because everybody now is very wanting of AI. I think that everybody today who's kind of actively using the internet would be a little upset if AI just disappeared tomorrow and like all of that just,
How would we write our emails?
Yeah, exactly. Like we'd go back to the dark ages, right? But the problem is that AI data centers, they require so much, it's basically an exponential scale. So, and this is, by the way, is why one of the reasons why NVIDIA, their stocks went through the roof was because they started supplying all the GPUs and processors that these companies needed. But these data centers will require so much power consumption that each one of them itself will need its own little nuclear power plant to provide its own electricity, right? So, but until that comes, they're relying on current grid.
Yeah.
Right? So because until they develop their own little power plants, well, they're now on the grid. And so you have a massive spike in demand. And it's not like AI is going to cap, right? It's not, it's not some asymptotic, logarithmic kind of like, well, okay, for the next 5 years, energy, like data centers are going to keep growing because AI is going to get more complex, but then it's going to stop. No, it's just going to keep going.
Sure.
Right? And that's kind of the metric here is that if you want AI to continue to get better and better and smarter, you need more processors. It needs more and more. And I don't think anyone is going to say, okay, it's fast enough, right? We can stop it here, right?
Sure.
And so, no, it's going to continue to get bigger. The demand is going to continue to grow. And as a result, you're going to need more and more energy. But by having more of a demand means several things. One, you need more power plants. And two, you have a bigger demand on the current grid, and that's going to strain it.
Well, and also if it's already taking 36 months minimum to create a new substation, if there's multiple reasons for creating new substations, i.e. response to attacks and also response to increasing power consumption needs, that's going to slow down the process.
Well, that for sure, but realize that building a substation is, ironically, much quicker than building a power plant. So your nuclear power plants, they like as far as I know, they're all trying to go nuclear, which is good. Nuclear is exceedingly green. But to build a nuclear power plant, especially with all the regulations, it takes a long time. So, I mean...
Well, it takes a long time with regulations to build a substation.
Yes, that is true.
Which is a fraction of the complexity.
That is true.
Let's talk a little bit about that. Let's talk about like why does it take so dang long to build these things?
So, in Denmark, you can build a wind turbine in about 1 year.
That seems pretty fast.
Okay, so in about 1 year, roughly, you can build one wind turbine. In Germany, it's between 5 and 7.
Why?
Because of red tape. Because Germany is exceedingly bureaucratical. There's a lot of people who make the misconception of saying Germany is efficient. And it's like, no. They're bureaucratical. There's a big difference between efficiency and bureaucracy. And the problem here is that now you can argue it's good or it's bad or, it's trade-offs, right? As Thomas Sowell always says, there's no good or bad. There's just trade-offs. But the downside here is that if something were to go offline and you do have all of that red tape, you can't just turn around and fix it, right?
Sure.
You have to go through all the red tape. Now, the politicians may decide for emergency reasons we're going to sidestep all the red tape, but that's kind of cheating. Because at present, they've put all of this red tape in place where it does take an astronomically long time to build things. And as a result, when you need to scale up, it's hard.
Well, and also nobody wants to plan their lives around a government exception coming through.
Well, yeah, you can't. You literally couldn't. I think it would violate your fiduciary duty if you did that way.
Sure.
But yes. So I mean, it's basically a lot of this comes down to red tape. And I mean, if I remember correctly, I think France has the record for speedy nuclear power plant creation, and it makes sense, right? They've been making power plants since World War II. They've been making nuclear power plants since World War II because they wanted the nuclear bomb. But that's a different history lesson. But they're very, very good at building nuclear power plants, and they can do so very fast. Whereas other countries, like in California, for instance, they can build nuclear power plants, but it takes them forever to do it because of the red tape.
Sure.
And then you have countries like Germany, which got really scared after Chernobyl and didn't seem to understand how nuclear energy works, and now they shut down all their nuclear power plants, and now they're turning around and saying, well, maybe that wasn't a good idea.
Once you kind of lose capacity, it becomes more onerous to restart.
Yes, and so it's one of these things where it can be very tricky, especially with all the red tape, because not only do these things take a long time, but it takes a long time plus add 5 years of red tape on top of it.
The interesting thing about that is the fact that there's so much red tape, ostensibly to make sure that these things are produced safely, and they aren't going to melt down or fail or, all of these different things. And yet we've spent, the past hour discussing how there's very little to no red tape or even like a checklist of security measures that they need to follow to make the substation safe from these very simple attacks. It's a little bit strange. It's a little bit off balance.
Well, it's exceedingly off balance, and I would imagine the reason why it's so off balance is because they don't actually ever consult anybody on the offensive side of security. They do a really, really good job at talking to the compliance guys. They do a really, really good job at talking to the defense guys. But the problem is that if you only ever ask the defense and the compliance, and you never talk to the offensive side of things, you will always get a false sense of security. Because you'll never look at it through the lens of like, okay, well, how would a bad guy actually do this? Like, have you ever actually been tested? And the problem is that when the blue team is testing the blue team, it's not real.
It's a totally different mindset.
Well, yes, because they are looking at it through, it's kind of like when you're running a pen test and the client says, well, that's out of scope. It's like, okay, well, I will run the pen test in the way that you have told me to do so. But an actual bad guy, there is no out of scope.
Sure.
Right? So it's one of these things that, yes, when you're running these types of tests, you really, really need to bring in all three pillars of security, because if you don't, you're going to get a false sense of security. Think of it this way. Imagine for a moment that you have all the compliance tools, you have all the things you need, but there's no defense. Right? Okay, so you've got in a warehouse somewhere, you have all the firewalls and the DMZs and the honeypots and everything that you would need to be secure. And it's sitting all boxed up in a warehouse. And maybe you have 5 times more than you would ever need to protect your server. Mm-hmm. Okay? But without the defensive side of things, it's useless.
Sure.
And so you need all of these things in order to actually have any real semblance of security. And the problem is that often the offensive side of things gets completely overlooked.
And I know you're probably going to say something along the lines of it depends, but to give some at least general advice, imagine an energy infrastructure client comes to you and actually does try to pick your brain as an offensive expert on these things. What are you going to talk to them about?
Well, as you said, it will depend on what kind of energy they're producing, where in the world they're producing it. So, for example, I would give very different answers if I was talking to somebody, in Ukraine right now versus in Germany.
Sure.
I would also give very different answers if I was talking to an offshore energy producer versus an onshore energy producer. So it would depend on what are the realistic threats in your area. So, for example, for an onshore, let's say we're talking about just substations.
Yeah, that might be a good one to pick.
So if we're talking about substations and we're talking about onshore substation, or like something that's, on land, well, your biggest risk is going to be somebody physically damaging the substation, either with a rifle, explosive, or something. It's not really likely that the person's going to hop the fence and go in with like sledgehammers and start banging away at something that's carrying thousands of volts. Because it's
not for long until they get electrocuted.
Exactly, right, exactly. So that's not a realistic threat. Plus, I mean, if you're using sledgehammers and stuff, one, hopping the fence alone, you should have at least short-range sensors, fence alarms, cameras, something that'll alert security. So that's not a realistic threat that you should be super concerned about. But you should definitely be concerned about some type of an explosive or anything at distance, like a rifle. And so from that, the ease, again, go back to the Fort Bragg instance, right? Super easy to pull off. However, if you do damage an onshore substation, you have mobile substations, right? So the remediation to this is twofold. One, hopefully you have extra substations that can reroute the power. And two, you have an emergency mobile substation that you can bring on board and fix the problem. So in this instance, the probability of this happening is still low, but you have redundancies and resiliencies that can, take over and resolve it. An offshore substation, the probability is less because you got to get a rifle and guy and get on a boat and go out, several miles out to shore and then shoot the thing. So the probability of that happening is lower. But if it were to happen offshore, do you have any way of solving it? Or is the entire project scrapped? Right? And so you might have a higher, okay, everything is kaput, the sky is falling, there's no way to fix this, we're going to be down for years at a time because we have to disassemble the entire platform to take it apart bit by bit to replace the thing. So at that point, it's like, okay, so the probability of this happening is less, but if it were to happen, we have no solution for this.
Sure.
Right? So it's one of these things that it really does depend on who's your client and what are they producing and where are they producing it and all these kinds of things. And then also what their budget is. Because, you can't say, well, just create a giant steel cage around an offshore substation. It's like, okay, come on. But you can absolutely kind of give them ideas on like, okay, well, maybe you should consider this, maybe you should consider that. What we talked about earlier, right? Onshore substation, a concrete barrier. Some type of a HESCO barrier, especially around the critical parts.
Well, yeah, my goodness, you put concrete medians on highways for miles and miles. Why couldn't you?
Right. So it's one of those things that it's not a difficult thing to do. It's low cost. It's it doesn't like really require a lot of like advanced engineering or anything else. And it would force the attacker to basically give up that attack method. Not saying they can't still damage the substation, but you at least couldn't stand off at distance and damage the thing. So it's things like this, right? Like, I mean, you would just look at the process, look at the energy generator, how is it generating power, where is it going, etc., and then look at what would a realistic bad guy do, and then think of low cost but effective ways to resolve it.
Sure. So then, since I kind of knew it was going to be an it depends question, but if we can't really talk about like concrete remediations, I'd like to talk a little bit then about like the mindset shift, because like, would you say are physical security professionals prepared to discuss these energy infrastructure questions? Do they have the information they need to be helpful to their clients on this topic? Since it historically has not been one that's been much discussed.
Yeah, this is a very, very deep topic, and we could have a podcast about this alone. A lot of people, I've talked to people who are legacy cybersecurity guys on the defensive side. I mean, they're in their 60s, and they're like, I've been doing this forever, blah, blah, blah. I had a conversation with somebody once, very high up in a European energy company, and they told me that physical risk to substations, and I'm quoting him here, physical risk to substations is of no concern because they have firewalls and things that would prevent any type of an attack. He genuinely, earnestly did not understand.
Did he think a firewall was an actual wall?
No, he genuinely did not understand actual physical risk. He had spent his entire career protecting these things from the internet. And he had no real intuitive concept of what if I just shoot the thing, right? I tried to explain this to him, and it was literally beyond him. So you will have problems with people who have, like, they can't wrap their head around things like this. But, there's the other problem of when you're talking about a business. Well, businesses are in the business of making money, right? That's the whole point. They're providing a goods or a service, and they're trying to make a profit off of it. If you come to a business and you said, hey, all of this stuff that you've been doing for cybersecurity, good for you, but there's this whole other genre of security that you're failing at and you're going to need to fix. Well, they've been good. All of their security advisors up until this point have been telling them they're good. They get a gold star, they're compliant, etc. And here you are coming along and saying, no, you need to consider this whole other genre of security. And that's going to cost you money, and it's going to cost you time, and this and that. So there's also going to be apprehension from clients to get on board with this, even though, in my opinion, it is the right thing to do, because there is going to be an immediate, cost.
But there is also, the compliance aspect of this is changing with different EU regulations that are coming into effect or have come into effect.
Yeah.
Because the energy is critical infrastructure.
Yeah, so there are a lot of new compliance laws around the world that are starting to incorporate physical security more. I know that the proposed update to HIPAA, for instance, there's a line in it that I actually laughed about because it said, we no longer suggest physical pen testing. It is now a requirement. So that was kind of cute. Previously it was just like, well, we suggest you do X, Y, and Z. But yeah, there are regulations that are now coming out all over the world that are now treating physical security in the way that it always should have been, which is an actual threat.
Gotcha. Well, is there anything else that we should discuss in terms of physical security of critical infrastructure that we haven't talked about already?
I mean, just look, think of it this way. Realize that, go back to what I said previously, where I said, if you needed to hack in to the power grid, think of all of the training, the tools, the expertise, and the techniques that would be required to not only get in, but then to actually do anything, right? Okay, so if you find a website with a back door or something and you manage to get into that back door through some privilege escalation or social engineering or whatever, okay, that's one thing. But now you have to actually do something, right, to actually damage things. And you're talking about something that requires a lot of training, a lot of skill, a lot of time, probably a team of people. But you can accomplish the same kinds of things with one idiot with a gun, right? If you know where to shoot.
Sure.
And so the problem here is that the bar of entry, the method of what it takes to actually cause these problems, is so far lower on the physical side of things that you need to treat it as the threat that it is.
Mm-hmm.
And I think that a lot of countries have not quite caught up to that yet. They haven't quite figured out that, oh, well, we spend millions of dollars a year on cyber defense, but how many clients, how many people listening to this have ever dealt with a client before and they've said, well, we don't know why we should hire you to try and break into our building because we know you could get inside.
Mm-hmm.
And it's like, okay, well, now flip that. What if they said the exact same thing about the cyber?
Yeah.
Right? What if they said, well, we don't need you to pen test our website because we know that you could catastrophically compromise us.
Nobody would want to do business with them.
Nobody would want, imagine if that client was a bank. Right? Imagine if a bank said, well, we don't want a cyber pen test to test our bank website.
Any organization holding any of your data or money.
Right, exactly. And so that's kind of the point, right? You start to realize how fragile they are, and they seem to know it. Most people seem to understand how fragile and how vulnerable they are to these things, and they need to kind of catch up. They need to catch up and realize that the bar of entry, the bar of what it takes to actually do catastrophic damage on the physical side of things is so much less than the cyber end of things that you have to treat it as the real risk that it is.
Yeah, you shouldn't just be praying that it doesn't happen to you. Well, Brian, thanks for talking to us today about the fragile nature of our energy infrastructure. I can't say I feel safer, but I do feel better informed.